This question says, which chord is most suitable for holding the pole? Is it chord A, chord B, or chord C? So these chords are used to hold the pole, and specifically they do this by restricting movement in the counterclockwise direction, or in other words, they oppose counterclockwise rotation of this pole. And they do this by applying a moment in the clockwise direction. And the ability or efficacy of each of these chords to do so depends on two main parameters. The first is the moment arm, which is a function of where these chords are attached to the pole, and the second is the angle with respect to the pole. So for example, for C, that angle would look something like this, and we could call that angle theta. Now, the smaller the angle, the less tension in the chord, and if there's too much tension, well then these chords can snap, and that wouldn't be good because then they can no longer function to hold the pole. So we want the largest moment arm for the greatest moment, and therefore the most effective countering via this clockwise moment, and we want the smallest angle to reduce the likelihood of these chords snapping. So if we look, A is connected to the lowest point on the pole with respect to chords B and C, which means the moment arm goes from this point of connection here to the base. Now, the moment arm for B and C is larger because it's connected higher up on the pole. So the moment arm for A would look something like this, and we can call this DA, the moment arm for chord A. And then the moment arm for chords B and C would look something like this. So this is D, the moment arm for B and C. Now, because B and C have a longer moment arm, they will have better countering of that counterclockwise rotation. Now, then comparing between B and C, we see that C has a smaller angle than B, which means it will have less tension and therefore be less likely to snap. So chord C is therefore most suitable for holding the pole. It has the greatest moment arm and the smallest angle. Answer is C.